Let's start this video with an example. It's probably going to be the bulk of this video. So go ahead and pause here if you want to copy this down. Okay, you got it. What are we looking for? We want to find the shear, normal, and bending moment at points B and C. Okay, so that means we're going to make an imaginary cut through point B, find the unknowns here, and we'll make an imaginary cut through point C and find the unknowns there. So let's go to it. Now the first step here is going to be find the unknowns. I've got a fixed support here at point A, so I need to find those reactions. I mean, go ahead. I'm gonna try to condense this video. I'm gonna say go ahead and pause it here. Find the reactions at point A. You really need to be able to do that at this point. Go ahead and pause it. Find the reactions at point A. I'm gonna do the same. All right, how'd you do? So I found my reactions here. I've got the X is just this 20 kip force that's out here at the end. The sum of these is only minus 60, so that's what AY ends up being, is that balance. And then your reaction moment. Don't forget, this is a fixed support here at A. So a fixed support is going to have a reaction moment that we need to find. And that's going to then carry through the rest of our calculations. Okay. Now, what are we looking for? We're looking for the internals at B and C. We could start here at B. That's real simple. We're saying B is 2.5 feet from point A. So my personal preference is I like to draw everything on the left-hand side of the cut. You don't have to. You could draw the right-hand side of the cut if you like. I'm going to draw the left-hand side of the cut. The left-hand side of the cut, now point A is on this left-hand side, so everything that's here needs to be applied here. Now I've found values for these. I'm going to go ahead and apply them. You can write AX, AY, and MRA and draw them as you've drawn them here. But if you've actually already found them, you can go ahead and draw them in the correct quantity and direction. I've got 20 kips. I had originally drawn AX positive. I found AX to be a positive 20 kips. I originally drew AY as positive, and I found it to be a negative 60 kips. So I'm going to draw it as a negative 60 kips. Again, kip being a kilopound. And then I originally drew MRA in the counterclockwise positive direction. I found it to be negative. So it's actually a clockwise moment, reaction moment of 350 kip feet applied at this end. And again, I've drawn into this guy, and we said in 2D, when you're drawing the left-hand side of the cut, your normal is in the positive X, your shear is in the negative Y, and your bending moment is in the counterclockwise direction. If you draw everything on the right-hand side of the cut, you flip those. But I've drawn the left-hand side of the cut, so I need to draw shear in the negative Y, the normal or the thrust force in the positive X, and the bending moment, the internal bending moment, in the counterclockwise or positive direction. And then the problem's asking us to find these. And you can label these as point B. Since I've got two of them, I'm going to find these at B and I'm going to find these at C. So I'm going to label these for point B and go ahead and write your equations here. I think you can, this one's pretty simple, right? I think you can say, well, sum of forces in the X direction equal to 0. That's going to yield you that the normal force is going to be a negative 20 kips. Right, I've drawn it in this direction. This is the sign convention, the typical traditional sign convention. It's actually in the opposite direction to counteract this one, so it's actually minus 20 kips from the normal sign convention. Sum of forces in the Y direction equals 0. I've got 60 kips going down, and then I've got the shear also going down. So the shear at point B is going to end up being a negative 60 kips. Right? I think that's probably clear, but let's just make sure. Sum of forces in the Y direction, I've got minus 60 kips minus the shear force at B. These add up to be 0, so the shear force at B must be a minus 60 kips. I did the same thing with this one. Bending moment. Sum of moments, I could take them about point A or B. Either one's fine. I typically just go ahead and take them about point A. Set that equal to 0. Right, now where these others, these have just been equal to the other applied force of the reaction. This one's going to be different. Right, so sum of moments. I'm going to go ahead and add my couple moments first. I've got a positive bending moment at point B, and I've got a negative couple moment over here on the left of 350 kip feet. And then what else do we have? Well, remember, I've got a bending arm, moment arm here of 2.5 feet. If I'm taking moments about point A here, this shear is causing a bending moment as it's drawn in the counterclockwise, as it's drawn, it's in the clockwise or the negative direction. So minus the shear at point B times the distance of 2.5 feet. Notice this shear has a negative sign. So when I solve for this moment, the bending internal moment at point B, I'm going to have positive 350 kip feet plus my shear at B. I'm going to plug in for the shear at B minus 60 kips. And that's going to be applied at a moment arm of 2.5 feet. So what am I going to have here? Pause it and double check my calculations. I'll be right back. Okay. I had to talk it through in my head and make sure I have written in my notes here that it is a positive 250 kip feet. And I looked at that, I'm like, is that right? I think that's right. Yes, I'm comfortable with that. Okay. All right. Based on this logic, this is what I want you to do. I want to pause here. I'm going to go ahead and pause it too, and then I'll write out the solution. But remember, we're going to cut this guy at point C. So go ahead and pause it. See if you can do the arbitrary cut at point C here, based on what we talked about earlier about how to draw these different diagrams. See if you can find shear, normal, and moment at part C based on what we've done so far. Okay? Okay, I'm going to pick up in just a second, but I just wanted to show you. This is so satisfying. I hit the end of a tablet of engineering paper. I just wanted to share that with the world. That's a rare feat to do. All right, I'm going to pause it and write us a solution for part C here. All right, I thought it might be worthwhile to go ahead and talk about the moment equation here as I write it out. I guess I'll go ahead and show it anyway. I didn't intend to actually start the video back up with these shown. But here we are, right? So the forces should be pretty straightforward at this point, right? Hopefully we can do these. The normal component is still just the minus 20 kips, the same as it was at B. However, at point C, I now have these other two forces are engaged on this left-hand side. So that changes what the shear at point C is going to be a different value. So as I go along this beam, the shear value is going to change. And then if I look at the moment, if I do some moments about point A, again, I'm going to start with a couple moments. I've got MC minus this 350 kip feet. And then I've also got some distances here. I've got 5 feet, 5 more feet, and then 2.5 feet out there. So this is causing this 80 kips is causing a positive. So it's 80 kips at 5 feet. Again, it's a positive moment caused by that 80 kip foot or 80 kips. It's causing counterclockwise rotation. 50 kips is causing a clockwise or a negative rotation. So minus 50 kips. And that is at a distance of 10 feet. And then finally, also causing a clockwise or negative, so start on the second line, minus the shear at point C, and that is at a distance of 12.5 feet. Now I've already got a value here for shear, so I could plug in here if you like, but I'll just go ahead and solve. You got MC is going to equal positive 350 kip feet. This is going to be plus, or I guess this is going to be minus 80 times 5 is 400 kip feet, if I'm doing that right. This is going to pick up a positive sign when I move it to the other side of the equation, so the 50 is going to cause a positive 500 kip feet. And this is going to get added, but I'm going to plug in for VC this negative value plus a negative 30 kips at a distance of 12.5 feet. And I'm going to go through and do those calculations. I have written in my notes here, if you get something different, let me know, but I've written in my notes here that MC ends up being 75 kip feet. Now here's where we're headed with this. Remember earlier I said, notice the shear is one value here. Now the normal doesn't change. The normal stays the same throughout. But notice the shear changes. At point B it's 60 in the negative direction. At point C it's down to 30 in the negative direction. And notice the moment's also changing. The moment was a positive 200 kip feet here. It's all the way down to 75 kip feet at point C because the loading changes as I move throughout. If I cut into this beam at different places, I'm going to expose the same three components here, the same three quantities, but they're going to solve out to have different values mathematically. What we're actually going to do then in the next set of videos, and the next part of this set of this chapter, is we're going to start looking at, okay, can I plot this as a function of x as I move along this beam loaded this particular way? Can I plot, if I call this the x direction, can I plot what shear and moment look like as I move from one end of this beam to the other? And that's really going to be kind of our goal for the rest of chapter 7 in the next couple of videos, is to really look at that and plot these things as functions of x. Okay, I'm going to stop there for tonight myself, and I'll pick up on these in the next time I have a chance to record some videos.